Hey guys, we had our Zoom meeting yesterday and went over the first concept of radians and the difference between those and degrees. And we're going to do a little bit more on that in this video and how to convert between the two. And it's going to be a bit of a learning curve after that because we're basically just going to work in radians from basically after today. So today's video is quite important to learn how we convert between the two and how the two are actually related to each other. Okay, so I'm going to switch over here. Um, I was really excited to go for a bike ride today, but then I went out there and it rained on me. And I'm a fair weather rider now, so I had to come in. So only got 10K in, so that's not very impressive. But um, I will try to go out tomorrow, hopefully. So, okay, so let's take a look here. So that looks familiar, I think. Yeah, so let's add on to that. Okay, so I'm going to zoom up here. Okay, so we looked at using our calculator to work out certain values of radians and degrees, and we saw that this chart here, let's go back here, this chart between 360 and 2 pi and 180 and pi and stuff, those are really important numbers for you to make mental note of, because you're going to see them time and time again, and eventually they'll just become second nature to you. So I'm going to turn off my video here because I'm going to get really close to the screen, and let's just flip this around so I can write on it. Okay, so let's take a look at just a simple question first of all, and it's going to deal with angles and standard position, and we're going to work with degrees first. So let's just start off with something we've already done here. So let's say that you're given the angle theta, and you're told that theta is equal to, let's say, 200 degrees. Okay, so 200 degrees. And so why don't you sketch that in standard position and find your reference angle. Once again, I would encourage you to pause the video and see if you can do that on your own. Okay, so angles in standard position have what we call initial arms, and the initial arm is always along the x-axis, so it points to 0. And then we have what's called our terminal arm, which is where the angle stops. So 200 degrees would rotate past quadrant 1, past quadrant 2, and go just into quadrant number 3 here. Quadrant number 3, and that would be approximately 200 degrees, say. So we have to show the terminal arm and the arc itself. Now the reference angle here is the angle between the terminal arm and the x-axis. So that would be 200 minus half a rotation of 180. And so that reference angle must be 20 degrees. What I didn't say in my video yesterday is that reference angles are always considered to be like the absolute distance. So they're always positive. It doesn't matter how the angle rotates. So let's give you an example of that, just to sort of make sure we're okay with that. So let's say you're told that angle theta was equal to negative, let's say negative 210 degrees. Okay, so if we were to sketch that, we have to now realize that the angle is rotating clockwise now because it's a negative angle. I always thought that was kind of strange when I learned that positive angles rotate counterclockwise, but negative angles rotate clockwise. So if we were to go start at our 0 point along here, we would have to start to rotate this way. And of course, that would be negative 90. That would be negative 180. And if I went all the way up to where it says 90 here, that actually would be negative 270. So my angle must say somewhere in quadrant number 2. Okay, so that is negative 210 degrees approximately. Now the reference angle here would be this angle in there. There's a couple different ways of doing that. One is I wouldn't even worry about the negatives right now. I would just think of that angle as being 210, and you're going to have to minus 180 from it. So 210 minus half a rotation, giving you a 30 degree reference angle. But some students might say, well, look, that's a negative rotation. Isn't it negative 30? Like, isn't the reference angle negative 30? And it's not. The reference angles are always positive. They're considered to be absolute distances. So they're really not telling you direction. They're just saying this angle is 30 degrees. And in the question before that, the angle was 20 degrees for the reference angle. Okay, so here we're going to take a look at our radian definition again. So 1 radian is the angle created when the arc length is equal to the radius of the circle. And it's quite strange definition, maybe, like, you know, probably more strange. Like, why would we care about that? And so if this was 1 radian, let's use 1 rad right now, then let's say the radius here in this picture was 5. So that was 5 there. Then the arc length, this distance here, would have to be equal to the radius because it says the angle is 1 radian. So this arc length would have to be 5 also. And of course, if this was 7, let's draw a line through that, then this now would have to be 7. So it's kind of interesting that it tells us sort of how big the actual angle is. And we worked that out last day. It's about 60 degrees. I think we got 57 point something. But more importantly, it also tells us the distance traveled by the object. So radians are kind of unique that way, that they actually tell us the angle size, but also how far you traveled. And so we can create a formula for this, which would be that the arc length, let's call it AL, arc length, is equal to theta r. So that means the angle theta multiplied by the radius r. Now, the only thing is this formula will only work if theta is in radians. So let's assume that this is in radians. So let's just give you a question like this. Let's say you were told a circle has a radius of, let's say, I don't know, 8, and a central angle of 2 radians. How long is the arc length? How long is the arc length subtended by this angle? So that's quite a mouthful of words there. Now the word subtended means across from in math. So if you draw a circle of this type, let me just see if I use my shape drawing. This is always a bit better. There we go. That looks more like a circle than above. So if I draw my angle here, so I'm just going to draw a line straight up here. Okay. So the question says that the arc length, sorry, what is the arc length? But it actually says that the radius is 8. So this would be 8, then 8 units. Now, it says the arc length is, so it says the central angle is 2 radians, which means that the angle here is obviously is double what 1 radian would be. So remember 1 radian was about 60 degrees, so this angle would have to be close to 120. So I'm going to approximate this. I'm just going to draw, I don't know, like obviously if I go straight across, that's 90 degrees. I go straight down, that's 180. So I'm thinking maybe like that, okay? So I'm just sort of eyeballing. I'm gonna say this is 2 radians, okay? So the question is, how long is this line here? How long would that be? Well, we know that the arc length is equal to theta r, okay? As long as theta is in radians. So since theta is 2 radians, that would be 2, and that really means it's 2 radiuses, or 2 radii. So 2 times 8 then, okay? So that would be 16. So we can actually get an actual distance traveled, whereas if I told you that there was this wheel and the wheel turned 120 degrees, and I said, how far did the object travel on the wheel? You couldn't really do that just using the degrees. You'd have to know the radius, and you'd have to maybe set up some kind of ratio to equate the two of them. But this formula works out really nicely for us to determine the arc length of the object traveled. So I'll put a box around that because that's something you should know for your test. We wouldn't give you that formula. That's something you should understand. So for example, let's just change the question up here, and let's say you were told that the radius, the central angle was 3 radians. Well, what that means now is that the arc length is 3 radii. So if it was 3 for the angle, then we would times that by 8, and that would give us 24. So it'd be 24 units long. So the radians are quite, they give you a lot more information. The interesting thing is that radians don't come with a unit. So like when we think of degrees, we always put like that little number up there, a little symbol up there, sorry, for degrees. And with radians, we would just say pi over 3. That's 60 degrees, same thing. But there's no symbol for that. So it's really important that you include degree symbols if it's degrees, and you don't put symbols in if it's not degrees. So if you said I went 45 degrees and you wrote this, 45, theta equal 45, that could be misinterpreted as 45 radians. It might seem kind of strange, but we'll talk about questions where you do more than one rotation. Okay, so let's talk about how we convert between the two, because I think that's sort of the big lesson for today. And we said that circumference equals 2 pi r, okay? And we know that theta would equal 360 degrees for one rotation. So let's just do our formula again, and let's say that I'm going to do this 2 different ways. One is the formula we did in class. So I'm going to say that theta over 360, so that ratio of the central angle. So you might just draw a picture here. And let's just do what we did before. Draw ourselves a circle. Good. And then we'll draw a dot here. And I'm going to say this is my angle theta, okay? And that ratio of the angle, the rotation to the degrees here would have to be equal to the arc length all over 2 pi r, the circumference of the circle. So those two ratios should be equivalent. And we talked about this in the video yesterday. So if my theta was isolated here, I would get 360 multiplied by the arc length over 2 pi r. So let's say this is 1 radian. So let's say it's 1 radian. So if theta is 1 radian, then we would say that the radius has to, the arc length has to be the radius. So we put an r in here, cancel those out. 360 divided by 2 makes theta equals 180 degrees over pi. Which if you work that out, it's around 60. It's a bit less than 60, but close, pretty close. So that's actually a really important ratio we have to use here. Okay, so that's our really important ratio. So I'm going to show you how we convert from let's say from degrees to radians. Let's do that first. Let's go from degrees, and we're going to convert to radians. We're trying to find out how many radians there. And I'm going to pick numbers that we've already worked out in the previous video, just to confirm that this actually is true here. So let's say that you were looking at an angle of 180 degrees, okay? And you want to convert this to radians. You're like, how would I get to radians? And I'm going to teach this as if you've taken a math or like a physics or maybe a chemistry course. And there's a process there where we multiply by certain ratios to convert units. So for example, let's say feet into miles, or maybe meters into kilometers. So Here's a quick conversion question for you to get you kind of thinking about this. So I actually did a run yesterday, and I ran 7 kilometers. Okay, true story. And let's say you were curious, how many meters did I actually run? Like how many meters did I run here? Well, I think for many of us, we probably just see 7,000 here. But let's just sort of show you the math on that, because that's what I'm going to do with this conversion here. So if we were to convert this from kilometers to meters, we'd want to divide by kilometers. So I'm going to put that on the bottom. I'm going to put meters up top here. And I know for every 1 kilometer, there's 1,000 meters. So that would cancel the kilometers, and that would give me 7,000 meters. And that's sometimes referred to as unit conversion technique or dimensional analysis. It's got a few different names for it. So I'm going to use the same idea here. I'm going to go from degrees to radians. So I need to get rid of my degree symbol. So I'm going to be using this ratio, but I can actually use the reciprocal of the ratio too. So this would be pi over 180 degrees. And just like how the kilometers canceled, I need to cancel the degrees. So sometimes you have to pick between this ratio or this ratio. So since degrees is in the top here, I'm going to need the ratio that has degrees in the bottom. So I put 180 degrees down here. And I put pi in here. And if I times that together, I get 180 over 180, which is 1. And so this is 1 pi. Now, another way to think about that, which might make a bit more sense now that we sort of talked about formulas and things you would have learned in previous years, is that if you think about let's see where we are. I'm going to draw this so it looks a little bit better. So I'm going to draw my grid here, turn this way, and hopefully I'm going to get this sort of close to being right. Maybe move it over a bit. Ooh. Anyway, it's pretty close to 90. Okay, so I'm going to get rid of that now. So that's 90 degrees. That's 180 degrees. Let's focus on there. So a half rotation. So imagine if you rotate it 180 degrees. So you did a 180 degree turn. Well, if you think about circumference, circumference is 2 pi r. So circumference equals 2 pi r. So 2 pi r here. And let's just say we're dealing with a circle with a radius of 1. So this would be 2 pi. So the entire distance around the circle is 2 pi. So you went all the way around. So you kind of went like loop, like that. That would be 2 pi. Now 180 degrees, that's half a rotation. That's half of 360. So if you did half a rotation in radians, this would be pi. So 180 and pi are equivalent to each other. Just one's talking about degrees and radians. So let's try just 2 more examples. So let's take 210 degrees, and let's convert that to radians. So why don't you guys try that? Okay, so I need to get rid of degrees. So I'm putting degrees in the bottom, and I'm putting my pi upstairs here. And we don't use a calculator here. I mean, you can reduce with a calculator if you want, but what I mean is we don't use pi in terms of punching it into the calculator and getting a decimal number. So we leave our answers in terms of pi. So you'll see all your answers will have a pi symbol in them. So if I reduce this, I know I'm going to get, well, let's knock out the zeros, 10 divided by 10. I got 21 and 18, and I know 3 would go into both those numbers. So 3 goes into 21 7 times, and then I have a pi. And then I know 3 goes into 18 6 times. So 210 degrees would be the same thing as 7 pi over 6. So let's say we're trying to go from, let's say radians, so you're in radians, and you're trying to go to degrees. So that's your goal here. Okay. So let's say you're given an angle of 5 pi over 4. Let's make this one easier, just because it's the first one we're doing. Let's say you have a measurement of pi over 3. Okay, and you're curious how many degrees is pi over 3? What would that be there? Well, I'm going to multiply by a conversion factor, and once again, I have to choose between this one or this one. Those are my 2 choices here. And what I notice here is that I don't have a degree symbol. In fact, I'm trying to get degrees. So that would mean I'm going to put the term that has degrees on top and divide it by pi. So here, if I multiply 2 fractions, I times the numerators, and then times the denominators. But I'm actually going to do a cancellation method here because I think it just works better here. And I'm going to say, well, that pi divided by pi would cancel, so the pi's would be gone. And then I've got 3, and I'm going to divide that into 18 first. So 3 goes into 18 6 times, and then 3 would go into 0 times. So this would be the same thing as 60 degrees. So when you try this next one on your own here, so let's try the one we were going to write here, which was, what was that question before? 7 pi over 6. So let's try 5 pi over 4. And once again, use your conversion factor and try to work that out. Okay, so same as before, I don't have any degree symbol here, so I'm going to choose the fraction that has the degree symbol in the numerator. So that'd be 180 over pi. And then I'm going to see if I can do some simplifying here. It's a bit easier sometimes. So the pi's would cancel, they're gone. And I know 4 goes into 18. Well, I know 2 goes into, sorry, I should say 2 goes into 180, 90. And so 4 would go into this 45 times. Okay. And then 5 times 5 is 25. 5 times 4 is maybe 40 would be 200. So 225 degrees then. Okay, so today's main video is about converting between radians and degrees and kind of the use of the formula theta r to give us the arc length. Okay, so let's try a question that kind of employs both these techniques, these things we've learned today. So let's say you have a circle. So a circle has a radius of, let's say, 4 meters. Pretty big circle. And a central angle of, let's say, 2 pi over 3. How long is the arc length? How long is the arc length? Okay, question mark. Of that angle. So so 2 pi over 3, we got a circle here, and let's say that I'm totally going to guess the size of 2 pi over 3. If you know the conversion, you can kind of guess roughly where it is here. So I'm going to draw a shape I think is going to be fairly accurate to it. Remember, pi is 180, so pi is 180 degrees. So this has got to be less than 180 because 2 over 3 is less than 1. So let's choose a color. Why are you not letting me choose this color? Okay, there we go. Okay, goodness. So I'm going to draw a line like this and say about there. Okay, so this is the angle 2 pi over 3. Okay, and I know the radius is 4. That's the radius there. And so I know the formula is arc length equals theta r. Oh, I'm sorry. I'm going to change this question on you guys. Sorry, let's change one here because we basically did a question just like this. So why don't we say the central angle is 120 degrees? Okay, so it's 120 degrees. Okay, and I'm going to erase this. So let's go back to the drawing board here. So that angle is 120 degrees, and the question is, how big or how long is the arc length that's subtending this? So how far is it from here to here? Well, first of all, we know that this formula will only work if this is in radians. And I have had students tell me this. If you guys see the error in this, they say, well, the arc length then must be equal to 120 times 4. So that would mean that arc length is 480 meters. And I look at those students and I say to myself, I say to them, really? Like look at that circle. Like look at that line. This is 4. That's 4 units. And so you think the distance around the entire circle is more than 100 of those, like it's more than 100 radians. So sometimes you have to think about the answer, think, does it even seem reasonable? So the error here, of course, is this part. You can't stick degrees into this formula. So we're going to have to go back to the drawing board and say arc length here must be equal to something times 4. So the 4 is right. It's just the arc length's not right. So we're going to take 120 and we're going to convert to radians. So I got to put my 180 in the bottom and my pi on top. So I'm going to have a pi up here. But let's do some canceling here. So I know 10 goes into each of those. And then I got 12 and I got 18. So I'm thinking 6s here. So 12 divided by 6 is 2. And 18 divided by 6 is 3. So this actually is 2 pi over 3. Okay. And I need to times that by 4. So I know 4 times 2 is 8 pi. And then all over 3. And I guess this would be meters. Now it might seem strange to leave it like that, but in calculus, that's just how the math geeks talk, and we just leave it like that. But if you really wanted to know, like say you were trying to measure it with like a ruler or something like that, although it's hard to measure a curve with a ruler, 8 pi divided by 3 is about 8.38 meters. So it's about that. But we wouldn't do that. We would just leave it like this. Okay, that's how we leave it. But that seems more reasonable than 480 meters. I think 480 seems like you're really high or something like that. Okay, so let's move on here. Let's do one more thing. Now this won't be part of the homework for the stuff I've just done. So you can call this maybe enrichment if you want, or advanced. Maybe let's call it advanced. Advanced sounds cool. But we will be covering this in a later video. But I just wanted to show you how we use radians like you've been using degrees. So let's say someone asked me to sketch theta equals, let's say 5 pi over 4. Okay, so they said sketch that and find the reference angle. Now, because the measurement of the angles in radians, we would expect that you give the reference angle in radians. In fact, we wouldn't give you marks, at least not full marks, for leaving it in degrees. So what we want to be able to do is teach you how to do this without converting all the time. But let's do conversion here. Let's convert this. So the first thing I want to do is figure out how big is 5 pi over 4. How big is that value? So I'm going to convert this by timesing it by 180 degrees over pi. We did this question earlier, but the pi's would cancel and 4 would go into 180 45 times. And if we times that together, we get 225 degrees. So I think if you've done the previous homework, this actually is a fairly easy question to do now. So you would say, okay, well, that would be 180. Down here is 270. So 225 must be somewhere around there. Okay, that's 225, sorry. And the reference angle now would be the angle between the acute angle between the terminal arm and the x-axis. So I'm going to go 225 minus half a rotation of 180, which gives me an angle of 45 degrees. And now I might remember what that is from yesterday's video, but it might not. So let's take 45 degrees and convert that back into radians for the reference angle. So I'll put 180 down here and pi up here. Okay. Now, we noticed that over in this question, 4 went into 180 45 times. So 45 must go into 180 4 times. So this would be pi over 4. So we would say the reference angle is pi over 4. Now, there's nothing wrong with doing it that way, but it's quite cumbersome. It takes quite a bit of time. And what you will eventually do, once you get comfortable at converting and knowing all the numbers and stuff, I'm going to switch over here, is you will not go to degrees. You will eventually go, that's just a waste of my time. And so here's a quick way to do this here. So theta equals 5 pi over 4. Okay. So I would still encourage you to do it this way over here, but I'm just going to show you the way we're working to, because this is the idea of being a bit quicker maybe. So I'm going to figure out where am I on the graph here. Okay. So I have to remember that it's 2 pi, so 0 or 2 pi. So 0 or 2 pi to do a rotation. And half a rotation would be pi. So here at the top, this would be pi over 2, because that's half of pi, right? And if I take 1 pi and I eat another half pi, then I would have eaten 1.5 pi's. So this would be 3 pi over 2. but I'll write it right now as 1.5 pi because I think it might make a bit more sense here. And maybe up here I'll write this as 0.5 pi's. Don't normally use decimals, but fractions are nice. But let's say you traveled 5 pi over 4. And all you really want to know is which quadrant you'd be in if you did that. So first of all, I try to figure out, am I less than 1 pi or am I more than 1 pi? Well, I know 5 divided by 4 is more than 1. So I've got to be past pi. But am I past here? Am I past 3 pi over 2? And so one way to do that would be to take 3 pi over 2 and turn it into something over 4 so you can compare it. So let's times top and bottom by 2. That would be 6 pi over 4. So 5 pi over 4 is definitely less than 6 pi over 4. So I'm going to say my angle is in quadrant 3, just like it was in the previous diagram here. And now what I want to find out is my reference angle. So see how we did this calculation here? We said take the angle 225 and minus 180. Well, why not take the angle 5 pi over 4 and minus half a rotation? So in degrees, half a rotation is 180. But in radians, half a rotation is pi. So I'm going to minus 1 pi. Now to subtract these two numbers, you need common denominators. So let's make this 4 over 4. And 5 minus 4 is 1. So pi over 4. Now, this might seem like a bit like, and that's just because you're new at it right now. It's a new concept for you. And once we get good at this, I'm sure you're going to find this is easy peasy lemon squeezy, as my daughter would say. We will, of course, she's not doing trigonometry, so maybe she would disagree with that statement. Anyway, so here we go. So we're gonna focus on the homework tonight being just converting from one unit to the other, and we're gonna do more of this kind of stuff in later videos here. So I'm gonna sign off here. Hope you guys have a good day.